Here we're going to be looking at what we call simplifying radicals. We're going to simplify these numbers. Word simplify. Remember when you learn how to simplify fractions, you basically wrote smaller numbers, right? You didn't write it as a decimal, right? So when I ask you to simplify a radical, I don't expect you to write a decimal. We're going to write this as smaller numbers. Interesting part is that we know how to deal with perfect squares. Right? Perfect squares. I'm not going to start with the square root of 1, but let me start with the square root of 4, the square root of 9, the square root of 16, the square root of 25, the square root of 36, right? 49, 64, right? Continues. If I ask you, what's the square root of 4? More than likely you will say 2. What's the square root of 9? 3. What's the square root of 16? 4. What's the square root of 25? 5. And then what's the square root of 36? Let me fix that 5. What's the square root of 36? You guys will say 6. The square root is a number that multiplied by itself give us the square root. Right? The square root of 25, for example. Let me take a look at this one. We said 5 because 5 times 5 is 25. But what if I asked you, what's the square root of 18? Can you think of a whole number that multiplied by itself is equal to 18? The list that I wrote in the center, that's the list of the perfect squares, right? It does continue. It does continue. It doesn't stop. But we call those perfect squares because they simplify to a whole number. Now, the square root of 18 is not a perfect square, right? I cannot think of a whole number that is 18, right? When I multiply by itself. I can type it in a calculator, and the calculator is going to give me a decimal, which is an estimation. It's not the perfect answer. It's not it. It is just really close to it. So I'm not going to ask you guys to give me an estimation. I don't want you guys to be close to it. I just want you to simplify it. So what I'm going to do, I'm not going to do anything to my 3 on the outside. So let me just write down my 3. What I want you to do when you're simplifying radicals, right? The square root of 18, when you're simplifying that, break it down into 2 radicals. And I want you to think 2 numbers that multiplied equals 18. They don't have to be the same number. Well, they could be different numbers. So I'm just thinking any 2 numbers that multiplied equals 18. However, one of them has to be from the perfect square list. So it could be 4, it could be 9, 16, 25, or 36. And I'm thinking, okay, 2 numbers that multiplied equals 18, but one of them has to be from here. I know many people say, how about 6 times 3? No, that's not a good list because the 6 or the 3 are not here. How about 9 times 2? Okay, that one works because 9, you guys see it? It's one of them. So again, let me say, you have to break it down into 2 radicals. One of them, they have to be both. One of them has to be from the perfect square list. Okay. Looking at square root of 9. What's the square root of 9? 3. Okay, so that became a whole number. What I'm going to do with this 3, I'm going to multiply with the number that was outside to begin with. So I'm thinking 3 times 3 is 9. So I have this as 9 radical 2. So it seems like I have a radical with a number outside and a number inside. That's how it looked like to begin with. It's just that my number inside is a little bit smaller. And then I ask myself, can I simplify it even more? No, not in this case. Okay, good. So my answer is 9 radical 2. We can easily write this, right? If this was a piece of paper, easily can write this. You guys can see how to write it. Now, how are we going to type this? The 9 outside of the radical, easy, right? It's just write 9. Now this radical 2 is actually what's giving us a problem. The way you guys are gonna write this will be RAD, all lowercase, RAD for radical. You see how the 2 is inside the house? I'm gonna put my 2 inside parentheses. So when the 9 outside, it's fine, but rad for radical and then 2. You guys see that? 9 radical 2. Don't copy the radical symbol from the internet. Don't call it square root. We are calling it radical. So this is how we're gonna write it. 9 radical 2. Okay, good. Let's take a look at question number 2. And I'm gonna think, okay, I'm not gonna do anything to the 5. So I'm leaving the 5 alone. But the square root of 175, radical 175. I have to break it down to 2 radicals. And one of them has to be from here, or it has to be from a perfect square. Then let's see. We might say, can I use 4? Can I use 4? Can 4 of them be it? Can you think of 4 times something equals 175? Well, let me grab my calculator, and I'm gonna go 175 divided by 4. If my answer is not a decimal, well, in that case, I can use 4. But I type it in, 175 divided by 4, and my calculator gives me a decimal. So no, cannot use my 4. 4 is not good. How about 9? Notice I'm gonna, oops, let me erase this. Let me emphasize, I'm gonna go down the list. 4 did not work. How about 9? 175 divided by 9? Nope, it gives me a decimal. Okay, how about 16? 175 divided by 16. Oh man, it gives me a decimal. Nope, not good. How about 25? Grab my calculator. 175 divided by 25, it says 7. Oh, not a decimal. So good, I can use it then. So now I know that 25 times 7 is 175. Yep, the square root of 25 becomes a whole number. Now multiply your whole numbers. 5 times 5. So I'm going to say my answer is 25 radical 7. Now, can I simplify this? No, I cannot. Okay, so there's my answer, 25 radical 7. I'm going to write this as 25 rad 7. Not bad, not bad. I'm sure. So how about when you multiply radicals? Okay, this is the thing we're going to be doing. Keep whole numbers with whole numbers and radicals with radicals. Do not mix them. So whole numbers are those outside of the radical sign. In this case, 4. That's my only whole number. If I had more than one whole number, just multiply them all out. And in this case, I just have the 4. And then my radicals. Multiply your radicals. I see 12 times 12. That's 144. Okay, now simplify. I'm not going to do anything with my 4. My radical 144, some of you guys are like, I can break this. I can break this as 4 times 36. Because the square root of 4 is 2. But wait a minute. The square root of 36, that's a perfect square as well. Isn't the square root of 36 6? I don't have radicals anymore. Yeah, when you think about it, the radical that was to begin with, the square root of 144, that was a perfect square to begin with. A perfect square is when they simplify to a whole number. Okay, yeah, that was a perfect square. And I can even see it here, right? You guys see 2 times 6? Yeah, that's right. That's what it was. Okay, so remember I said multiply the whole numbers. So I'm going to go 4 times 2 times 6. 48. I don't have any more radicals. Nice. So does that mean that sometimes when I simplify, I'm not going to have radicals in my answer? Yes. If I give you a perfect square to begin with, yes, you're not going to have radicals in your answer. Let's take a look at question number 4. Let me start by multiplying the whole numbers. -3 times -4. -3 times -4, that's +12. Now let me multiply my radicals. Radical 3 times radical 2. That's radical 6. Can we simplify that more? No, because I can break it as 3 times 2, but the 3 or the 2, neither of them are perfect squares. So that's it, 12 radical 6. Let me write this as 12 rad for radical 6. Wow, that was nice. So remember, when we simplify in radicals, looking at number 3, simplify to whole number. So the first part of your homework, kind of like question 1 and 2, when you're simplifying radical, don't be surprised if it simplifies to a whole number. Questions 3 and 4, when we're multiplied, multiply the radicals and multiply the whole number separate. Okay. Now, what happens when we divide? Well, fraction is basically division. So let me simplify first. What I'm going to be doing, I'm still going to keep my fraction, but let me look at my whole numbers first. 8/6. Simplify that. I'm going to call that 4/3. Right? I divided each by 2. That's basically what it is. Simplify a fraction. Same thing with my radicals. I'm going to keep this, in this case, as 2 radicals. Now, 20/18. Right? Simplify that. I want to divide each by 2. In this case, let me divide each by 2, so that gives me 10/9. Now, couple rules that we have to, well, a few rules that we have to have. We call this rationalize the denominator. Fancy wording. Rationalize the denominator basically means no radicals at the bottom. Okay? No radicals at the bottom. On the top is fine. If you have a radical on the top, make sure that it's simplified. Okay? And then obviously your whole numbers, make sure they're simplified as well. So no radicals at the bottom, and everything else has to be simplified. Good. Interesting part is that this one, square root of 9, radical 9, isn't that a perfect square? Isn't the square root of 9 3? So when I look at this, I have 4 radical 10/9. Because look, I just multiply those. Those are whole numbers now. 3 times 3 is 9. Now, no radicals at the bottom, so that's good. My radical that I have on the top is simple 5. Cannot do anything with it. And my fraction, 4/9, nothing I can do. So that's it. If we had to write this, pretty simple. Now, how about when we have to type it? Okay, focus on the top first. 4 radical 10. So I'm just going to write 4 rad 10. Remember, no spaces altogether. Because I was just looking on the top, 4 radical 10. The fraction, let me do a backslash. And then everything that is at the bottom of the fraction. So 9. So my backslash represents fractions. Everything that is before it is what goes on the top of the fraction. Everything after it, it's what we have at the bottom of the fraction. Everything all together. Make sure you don't add any spaces all together. So 4 radical 10/9. Good. So that means that sometimes they simplify that easy. Sometimes, yes. Let's take a look at number 6. I still have a fraction, but then we have 6/4. I'm going to call that 3/2. Right, simplify it. I'm just going to divide each by 2. Now my radicals, 10/6. Let me divide each by 2. So that gives me 5/3. And then you guys might say, Mr. Leonzo, we still have a radical at the bottom. Okay, yeah, we do. So the way I'm gonna get rid of it, let me multiply this by 1. When you multiply something by 1, the value doesn't change, right? But you guys might be like, you wrote a fraction. Yeah. When we have a 1 as a fraction, the top and the bottom look the same. So let me multiply, in this case, radical 3 over radical 3. The problem here, when I was looking at the radicals, my square root on the top, the radical 5 was not a problem. My problem was the one at the bottom. So that's why I chose 3 and 3. Instead of the 5, I wrote 3, right? Radical 3 over radical 3. I'm going to show you guys in a minute why. Because when I simplify the top, that is 3 radical 15. When I simplify the bottom, is 2 radical 9. But radical 9, it becomes a whole number, which is 3. So that means I have 3 radical 15 over 6. See how I got rid of the radical at the bottom? Nice, easy. Now, 3/6. We can do better. I'm going to call this 1/2. Radical 15, nothing we can do. So there, my answer is 1 radical 15 over 2. So if I had to write this, you guys can write 1 radical 15 over 2. Mathematically speaking, that's correct. Now, one thing, that when it is a 1 outside of the radical, it is okay if you don't write it. So if we had to write this, radical 15 over 2 is the same thing. So 1 radical 15 over 2, or just radical 15 over 2, if we had to write this. Now we had to type it, right? Okay. So I'm going to choose this to be my answer, radical 15 over 2. And the way I'm going to type that, I'm going to go radical 15 over 2. Now, if you do write 1 radical 15 over 2, you're fine. So simplifying for the first 6 questions was not that bad. How about when we have to square? It says square each radical. Make sure you read the instructions, right? I'm not asking you to simplify. I'm asking you to square. So what does square mean? When you multiply by itself. So I'm asking you to go 2 radical 5 times 2 radical 5. When you squared a number, basically you multiply by itself. It is okay if the number is a radical. It's a number, so it's okay. Now in this case, I know I have to multiply the whole numbers first. 2 times 2 is 4. Then I have to multiply my radicals. I know 5 times 5 is 25. So I have 4 radical 25. Interesting is that my radical becomes a whole number, right? The square root of 25 is 5. So now I just have 4 times 5, which is better known as 20. Let me take a look at my question number 8. 3 radical 7. So that basically means 3 radical 7 times 3 radical 7. When I multiply my numbers, that's 9. When I multiply my radicals, I get 49. Interesting is that the square root of 49 is 7. So then I have 9 times 7, which is 63.